Hello everyone, this is Horned Frog Engineering and I'm going to talk about how to convert from polar to rectangular and rectangular to polar. This is especially helpful specifically for AC circuits analysis. So for our imaginary numbers, we're going to use the letter J. Because that's what we usually use in circuits instead of letter I. Since this is mainly an engineering channel, we're going to use the letter J to represent imaginary numbers because letter I is usually represented as current in circuits. So let's get to it. First thing that you want to do is you want to memorize Euler's formula. So it's going to be x e angle theta. Sorry, not I. I just said we're going to do J equals x cosine theta plus J sine theta. This is going to be your real part, and this is going to be your imaginary part. So this is Euler's formula, and this is something that you're going to want to know. And you're probably going to do this so much that you memorize it anyway. So here's an example. What if we want to convert this? Let's say this is 100. This is a voltage of 170 E 45 J, and we want to convert this to a rectangular form. The way we're going to do that is we're going to use Euler's formula. And if you look at Euler's formula, x is represented by 170. So it's 170. This is 45 degrees, or this could be in radians, pi over 2. But we're going to use 45 degrees on this one. So cosine 170 cosine of 45 degrees plus J sine 45 degrees. And if you plug this into your calculator, this voltage will be represented by 120.2 plus, this is in volts by the way. Don't want to forget the units. Sometimes, yeah, we want to always keep the units. J 120.2, and this is in volts. So this is going from polar form, and by the way, this can also be written in shorthand form as 170 45 degrees. So that's another way to write this polar form, 170 and angle of 45 degrees. So we're converting this from polar form to rectangular form by using Euler's formula. But now now we're gonna go from rectangular to polar form. And rectangular form is going to be of this form. Is a plus jb. This is going to be your imaginary part. And the formula to get the magnitude is a squared plus b squared, square root of that. And then to get the angle, it's going to be arctan, or tangent inverse. It's going to be b over a. Assuming that if for arctangent or tangent inverse, this angle is going to be the output is going to be in the first quadrant or fourth quadrant. If your answer is supposed to be in the third or if the second or third quadrant, you're going to want to add 180 degrees or pi over 2 radians if the answer is supposed to be in the second or third quadrant. So just remember that, just be careful about that part. And for our example, we're just going to do something simple. That's going to be in the second quadrant, so we don't have to add 180. It's going to be 216 minus j 72. So you want to convert this from rectangular form, this is in rectangular form, to polar form. So the magnitude is going to be equal to 216 squared plus 72 squared and that's 227.7. The amps, voltage, so whatever the problem states, we're gonna leave this unitless. And then the angle is going to be arctan. It's going to be B over A. It's negative 72 over 216. And that angle is going to be negative 18.44. And if you look at this on a this is going to be an imaginary part and a real part. In the real imaginary axis, 216 is going to be over here, and then this is not 7.2. This is 72 is going to be over here, and this is going to be on the fourth quadrant, not the second. So you don't need to add 180 to this one. Now we're going to do an example in which we'll have to add 180. So this next example is going to be negative 210 plus j 60. So let's look at the real imaginary axis. Negative 210 is over here, and 60 is over here. So this is going to be on the second quadrant, so we will need to add 180 whenever we do our arctangent to find the angle. But first we'll get the magnitude. The magnitude is negative 210 squared plus 60 squared, and that's going to equal 218.4 for our magnitude. And the angle is arctan 60 over negative 210 plus, make sure you add 180, or if you're in radians, add pi over 2, since this is going to be in the second quadrant. And the answer that we get is 164.05 degrees. So I forgot to convert this to make this into polar. So let's start with example. We're going to call this example 1, example 2. So we're going to have our answers over here in the bottom. Our answers for example 1 for this part right here is 227.7 EJ negative 18.44 degrees, which you can also write this in shorthand form as 227.7 with an angle of negative 18.44 degrees. So that is our polar form for example 1. And example 2, our polar form is going to be 218.4 EJ 164.05, which you could also convert to 218.4 with an angle of 164.05 degrees. And that is our answer for getting to polar form. All right, now what if we wanted to use the calculator to convert this to rectangular form? So what you're going to want to do is you're going to want to put 218.4 exponential I times, you don't want to put the this part in degree in the calculator. You want to convert this to radians, and the conversion factor is 1 radian equals 57.296 degrees. So you're going to put 164.05 divided by 57.296 degrees, and then make sure you go to mode, and you make sure that you go from real to rectangular form for complex number version. And then this is going to give you the value of negative 210 plus 60j. And then to get from rectangular form to polar form, again, you're gonna want to enclose this in parentheses. Parentheses, close parentheses. Well, you could do it one of two ways. I should clear this. You can go to math, or go to mode, and go to polar form on the right hand side. Press enter, and that's going to be your answer right here. And this, again, this is going to be in radian mode. So if you want to convert this back to degree mode, you multiply this part by 57.296. So this is going to be your answer in polar form. And that's how you get from polar form to rectangular form using the calculator.